All right, guys, sorry about that. Some stupid thing shut down there after 15 minutes for some unknown reason. This is probably a new limitation that we're going to be dealing with now from now on. But I think we got down to somewhere around here, where we're just multiplying the square matrix by the column here, and we got down. I think we just got down to around here. So and then I just did this. The second one entry here is minus 110 because it's 40 minus 40 minus 110. And the last one here is 55. 110 minus 55 is 55. And so when you multiply in then by 1 over 55, you get 3 minus 2 and 1. And so you get x equal to 3, y is equal to minus 2, and z equal to 1. So now I'm getting paranoid about making sure this stupid thing is on. So yeah, it looks okay. So every now and then you'll have me kind of peering over the edge of this thing. It's ridiculous. All right. The next thing I'm going to do, I was doing this for the last half an hour with the thing turned off, and I was really good. I was in the zone, but now I'm not in the zone anymore because I have to do it again. But this next system of simultaneous equations is extremely important in engineering mathematics and applied mathematics in general, physics. It's a situation where you have simultaneous equations with a zero right-hand side. So let me just start off again by what the problem we started off with this morning. 2x minus y is that, and 3x plus 2y is equal to 4. Now, if you look at here, we've got 5 and 4. If we replace, and they're non-zero, of course, there's at least one non-zero. So if we replace these two by 0 and 0, what you have now is what was called a homogeneous system. Of simultaneous equations. Okay. Now, the important criterion for simultaneous system is that every number on the right-hand side must be 0. If you have only one number in, say, a system of 10,000 equations and 10,000 unknowns, then you don't have a homogeneous system. And you may think to yourself, this is very artificial kind of setup. And it is seemingly when you first come across this the first time, but it's not actually, it's very common. This kind of setup is actually very common piece of engineering and mathematics analysis. This happens more often than you would think. So it's very important that you get into your heads when you do what we're going to do next, because it is very important. All right. So a homogeneous system of simultaneous equations is we have all zeros on the right-hand side. Now, if one of these numbers, even if it's a very small number, like it's a very small number, 0.00001, for instance, if it was just that, you say, oh, that's very close to 0. Yeah, it is, but it's still non-zero. It has to be identically 0. It has to be exactly 0. Every number has to be exactly 0 before you can do what we're going to do next. All right. Now, this is very kind of esoteric, very mysterious, but this is as I say, and it takes a little bit of confidence to go into this thing now. But let's do this. I don't know if it's obvious to any of you here looking at these simultaneous equations what an obvious solution is. Well, a natural solution is, I suppose. But when you have a homogeneous system of simultaneous equations, there is always a trivial, what's called the trivial solution. And that's very important. You never overlook that. Okay, always. If I replace x by 0 and y by 0 in the first equation, I get 0 equals 0, which is true. And if I replace this x equals 0 and y equals 0 in the second equation, I get 0 is equal to 0. That's true. So therefore, x equals 0 and y is equal to 0 is always a solution. And this is called the trivial solution. And in engineering analysis, if you have a trivial solution like x equals 0, y equals 0, or if you have you don't have to have two unknowns. If all your unknowns are equal to 0 in an engineering system, typically what that's telling you is that nothing's happening in your engineering system, and it's not interesting at all. Nothing's happening. You've got a machine that's not turned on. Basically, that's what that's telling you. But if you have a solution which is said non-trivial, then there is something going on in an engineering system. And the question that arises, well, are there other solutions. So instead of in addition to x equal to naught, y equal to naught, are there other solutions? And the answer to this question is, and it's maybe a little bit surprising, but it's true, is yes, if the determinant of the coefficients is equal to 0. Now, usually, you want the determinant of the coefficients to be non-zero. But in this special case, if your right-hand sides are all 0, this is the condition that you want. You want your coefficient matrix, the determinant of the coefficient matrix, to be 0. All right? So let me just do an example for you. Okay? So here it is. Solve. Let's just do this one. 2x minus y equal to naught. 3x plus 2y is equal to 0. The first thing you do, folks, always, if you have a homogeneous system, you write down the trivial solution. Always. Do not forget that. The next thing then you do is you get the determinant of the coefficients. So the determinant of the coefficient in this case is 2 minus 1, 3 and 2. And when you get to the determinant of that, folks, you get 4 minus 3, which is 7. That's now equal to 0. Okay. So because of the determinant is not equal to 0, the only solution is the trivial solution in this case. So the only solution in this situation is the trivial solution. Okay, so now this is very examinable, guys, because I as I said to you, when I was in college, this was never, I just kind of eventually kind of began to understand this, but this was never kind of pointed out to me formally as something that you have to do. And it's a very, very important technique. It's probably one of the most important things that you do, because you see it so often actually in analysis. Okay, so if you have a homogeneous system of simultaneous equations, if the determinant is not 0, then you've only got the trivial solution, x equals to naught, y equals to naught. Let's look at an example where perhaps you don't have just the trivial solution. Now, so here's the second one here. So here's solve. 2x plus y is equal to 0, and 6x plus 3y is equal to 0. Okay, so these are two equations in two unknowns. And if you look at these system of equations, you notice first, it's a homogeneous system because the right-hand sides are both 0. Now, this doesn't refer just to two equations and two unknowns. You could have 10,000 equations and 10,000 unknowns. It doesn't matter. But all the right-hand side numbers are 0. So the first thing you write down, again, folks, is x equal to naught, y equal to naught. Again, then you get the determinant of the coefficients, which in this case is 2, 1, 6, 3. Which in this case is 2 by 3, which is 6, minus 6, which is equal to 0. So in this case, folks, you get happiness because the determinant in this case is equal to 0. So there are other solutions than just the first solution. There are other solutions. Now, what are the other solutions? Well, if you go back to the system of equations, number 3 here, let's just do 3. If you go back to number 2, can I call this equation 2? Let's call this equation 1. If you look at equation 2, you can rewrite that as 3 into 2x plus y is equal to 0, right? Isn't that true? Because you're just bringing the 3 outside. And because you've got two things multiplying together equal to 0, one of them must be 0. But 3 is not 0. So therefore, what you have here from number equation 2 is 2x plus y is equal to 0. So what you have in this system of homogeneous equations is really not two equations in two unknowns, but one equation in two unknowns. Okay, so there's an infinity of solutions, not just one solution, not just the trivial solution, but there are an infinity of solutions. And because therefore, what is the infinity of solutions? Well, you take any of the equations, any of this equation, either 1 or 2, and you solve for y in terms of x or x in terms of y. It doesn't matter. So you go back to the first equation and you can write y as equal to minus 2x. That is your solution. Okay, and it doesn't matter what x is. X can be arbitrary. X is any number, but if x is any number, y must be related to that value for x through this relationship here. So you can take x equal to, you can have any values. X, you can have 0, 1, 2. So if y in this case is 0, if x is equal to 1, y is equal to minus 2. If x is equal to 2, y is equal to minus 4, etc. And you'll see in this case, folks, that if for y is equal to minus 2x, it includes the trivial solution, x equals 0, y equals 0. So in this particular case, you can forget about that solution because it's in this formula. So in this case, the solution to the system of simultaneous equations on the top of the page here is y equal to minus 2x, where x is any value. And that's the solution. Okay, so this is a very, very important technique. And but it's only applicable, as I say, when all the numbers on the right-hand side here are 0. When all the numbers on the right-hand side are 0, you want the determinant on the left-hand side, the determinant of the coefficients on the left-hand side to be equal to 0. Now, if any of these numbers is non-zero, then you want the determinant of the coefficient matrix to be non-zero as well. So there's a nice little kind of symmetry here, and that's probably how you should remember it. But this idea here, guys, of homogeneous simultaneous equations having non-trivial solutions is surprisingly important. And it crops up a lot in engineering analysis, surprisingly enough. And it's a very, very important technique. Okay, and you need to get this into your brains now because you will see it later on. Is this examinable? Yes, it is. And we're going to be doing something on Friday, maybe, where we're going to be looking at using this, but maybe not Friday. Maybe Friday. We start it maybe. Yeah, we'll start maybe on Friday, but where you actually use this. And we start looking at things called eigenvalues and eigenvectors. And that's a very, very important problem in applied mathematics as well. But again, guys, very, very important. So let me just kind of summarize, if I could. I want you to contrast something like 2x plus y equal to 1, 3x minus 2y equal to 5, with 2x plus y equal to 0, and 3x minus 2y equal to 0. Okay? So, very, very distinct problems. You will notice here that one, let me just look, that equals 0 as well. Ooh, right? So I want you to contrast this system of simultaneous equations with this. If you look at the first one, you have a 5 here, which is not 0. So there's a right-hand side number which is not equal to 0. So therefore, in this situation, you want the determinant of 2, 1, 3 minus 2 not equal to 0. That's what you want in that situation. On the other hand, over here, because we have 2 zeros on the right-hand side, in this situation, you want the determinant of 2, 1, 3 minus 2 equals 0. That's what you want, because you've got zeros on the right-hand side here. So that's very, very important. Now, of course, if you look at the determinant here, it's 2 by minus 4, which is minus 4 minus 3, which is minus 7. That's not equal to 0. Okay, so in this case, that's good. So this is a good system. You can find out what x and y are. Here, because the determinant is not equal to 0, the only solution is x equals 0, y equals 0. Okay? So that's an important little kind of difference. Sometimes you want the determinant to be 0, sometimes you don't. Most of the time, to be fair, you don't want the determinant to be 0. But this particular situation, as I say, crops up very, very frequently. And as you're going through your engineering studies, you might see it, you probably will see it, almost certainly you will see it. And people kind of do this and will apply this, and you may wonder what's going on. Why is the determinant equal to 0 in this case? Because you have 2 zeros or 3 zeros or 4 zeros. You have all zeros on the right hand side. Okay, guys, I'm going to put up some more problems in loop. I want you to try that. I'm going to peer over here and just kind of make sure that this stupid thing is on still. Yeah. So I'm going to do a little bit more, put some more problems up on loop, I think. Work through the problems. Very important you do this. Of course, very important to get outside and maybe enjoy the sunshine today and come back and then start doing this stuff. But it's very important to keep on top of this. as well as all your other stuff. And you need to practice this. It's very straightforward, what we've been doing, but there is a lot of it. And we're going to be doing more on Friday and then more next week so that it kind of accumulates. Don't let it accumulate, because there will be an exam on this. I know it's a very special time and it's a very, very strange situation that we're all in, but there will be an exam on this. You need to be able to reproduce this stuff in May, in whatever format we ask you. It could probably be some kind of an online test. We're not sure yet. Okay. Connor hasn't told me yet what we're going to be doing. All right, because Connor is the boss. So this is get out and enjoy the sunshine. Come back and do this. Very important. And I will talk to you on Friday. All right, guys. Take care. Bye.